By weight, it is the most valuable spice on Earth. Yet the entire global supply chain is concentrated within a single, geographically vulnerable region. For decades, Iran's Khorasan province has dictated the market. This semi-arid belt alone has traditionally supplied approximately 90. Relying on open fields for a high-value global commodity is no longer a viable model. The ecological math simply does not hold. Natural climate failure is compounded by man-made trade barriers that isolate this concentrated supply from international buyers. Tightening international sanctions have frozen formal export channels, cutting producers off from the global banking systems required for standard trade. Even basic coordination has broken down. Regional internet blackouts have severed communication between local exporters and their foreign clients, halting logistics at the source. This friction has pushed the trade into the shadows. Roughly 10 tons of saffron are now smuggled out of the region every month to bypass banking and communication blockades. Moving this product now requires complex rerouting through secondary hubs like the UAE or Spain to mask the point of origin. While global prices rise, the Iranian growers see little of that value. Trapped by sanctions, they are forced to sell their diminished harvests at distressed prices to gray market intermediaries. Climate stress and geopolitical tension have fractured the legacy supply chain, forcing the industry to move towards an entirely different model of production. The primary catalyst for change is the pharmaceutical sector. Industrial buyers in wellness and cosmetics are aggressively securing global supply, but their requirements have changed. They are no longer buying a culinary spice, they are sourcing a chemical. Specifically, they are looking for the bioactive compound crocin. Demand is surging as clinical research explores crocin for oncology treatments, asthma reduction, and as a potent alternative to traditional antidepressants. But natural agricultural products are physically inconsistent. Raw threads harvested from the field vary too much in potency to be used for standardized clinical dosing. This has triggered a pivot toward high-margin liquid and powder extracts that guarantee a precise concentration of crocin and safranal in every batch. Open field farming cannot provide this consistency. Weather variability and soil degradation make it impossible to hit the purity targets required by modern labs. Saffron is being retooled. It is moving from a volume-based culinary trade into a value-based clinical extraction industry, requiring an overhaul of how the crop is grown. To meet chemical standards, the industry is moving toward controlled environment agriculture. Indoor facilities using aeroponics and high-density vertical farming are replacing the open field. This detaches the yield from the local weather. By using IoT sensors to manage temperature and humidity, growers can synthesize the perfect flowering climate, regardless of external conditions. These automated modules provide the stability that the Khorasan province can no longer guarantee. This data shows how soilless systems compare against traditional soil farming in both yield and chemical quality. In the first graph, the soilless system shows a significantly higher peak flowering rate that begins earlier in the season than the soil baseline. The quality charts confirm that indoor cultivation retains more of the essential bioactives, resulting in a product with superior concentrations of crocin and safranal. Efficiency is the secondary driver. Indoor systems allow for up to 4 harvest cycles per year, removing the bottleneck of the single annual harvest. These advanced systems also utilize automated stigma separation, significantly reducing labor hours and keeping post-harvest damage below 4%. By stabilizing the chemistry and increasing the yield, indoor farming is altering the unit economics of the entire industry. The next 10 years will be defined by this transition. The 2026 to 2036 forecast reflects a market in the middle of a massive structural pivot. Projections show the market value rising from $390 million in 2026 to $800 million by 2036, a steady annual growth rate of 7.4%. This growth is fueled by the commercialization of pharmaceutical extracts, not by a recovery in traditional agricultural fields. The market will take a decade to double because of the high cost of building new vertical farming infrastructure and specialized extraction labs. For major buyers, the draw is predictability. Factory-like production allows pharmaceutical companies to secure supply through just-in-time inventory models. The doubling of market value is a direct result of capital moving into agtech and biotechnology. As production moves indoors, the geographic map of the market is being redrawn. China is currently the largest buyer, absorbing supply to fuel its traditional medicine and premium gift markets at This Eastern demand is driven by high-volume use in traditional medicine and prestige consumption. Western nations like Spain and India are taking a different approach, using technology and strict origin certifications to control the premium extract market. This creates a global split. Asian markets drive the volume of consumption, while Western hubs drive the technological standards and laboratory verification. Competition is no longer about who has the best soil, it is about who owns the most advanced proprietary growing protocols. Over the next decade, saffron will finish its transition from an ancient, climate-vulnerable agricultural commodity into an industrialized, globally distributed